So we're going to take you through three different types of connectivity that we're focusing on. Bluetooth Smart, the sort of 802.15.4, 6-low-pan, and Web of Things type stack, and also cellular. And we've got three different speakers to come and talk about that, so hope you find this useful. So I'd like to introduce first Kevin to talk about some of the work we're doing on Bluetooth Smart.
Thanks. Can everybody hear me okay in the back? Or is that okay? Or all right. So as Simon mentioned, my name is Kevin Hamilton. I was here to talk a little bit about Bluetooth Low Energy, or sometimes you'll see it as Bluetooth Smart, or just BLE. There's a few names floating around, but we'll use Bluetooth Low Energy here, which is basically it's an extension, or it's a subset of the new Bluetooth 4.0 standard. You can see here just basically what is Bluetooth Low Energy. It's part of the new Bluetooth 4.0 standard that uses sort of a subset of the possibilities that are defined, but there's some specific objectives behind Bluetooth Low Energy. It uses the same 2.4 band, gigahertz band, so you can use the same ceramic antennas, and you have a huge variety of choices out there. And for 2.4 gigahertz, you don't have to worry about operating outside the ISM band. Now, specifically, what makes Bluetooth Low Energy interesting is that it's optimized for a very specific set of use cases or a very specific scenario, specifically for generally very short range, very low power, and generally low cost situations. Unlike maybe some of your previous experiences with Bluetooth trying to connect, where maybe it'll take 2 or 3 seconds to get a connection and you have to go into the control panel and turn the Bluetooth on, etc., etc. You have very quick connection times, and it's relatively painless for the end user. Typically, you can get a good connection in under 10 milliseconds, which is a significant improvement if you've ever had to fiddle around with your Bluetooth headset or whatever else, trying to get it to play well with your phone. So one of the trade-offs, or one of the specific design decisions made with Bluetooth 4 was to optimize things for very small packets and small amounts of data. You're not going to be streaming audio with the Bluetooth Low Energy device. It's optimized more for small amounts of sensor data on a regular interval. So you're limited to 27 bytes in the individual packets, and the goal behind that is to have very short packet deliveries and to enable the radio to go on and off as quickly as possible. Unlike traditional Bluetooth, there's no connection maintained, which is why you can run it for a significant amount of time on a coin cell, because there's no constant radio connection. There's a lot of small optimizations that take place to make sure that the radio is on only when it needs to be on. For example, I can keep updating my board with sensor values, and it will only transmit that value when there's actually a change to it. And you can customize the amount of time that happens between individual transactions based on your performance or your data throughput or your energy requirements. But it's optimized really for very sensor-oriented solutions without a huge amount of throughput, but where battery life matters. You also have a very simple data model intentionally to match this kind of use case. It's relatively easy to understand once somebody explains a little bit how the data should appear. It's relatively intuitive, as we'll see a bit later. So the biggest advantage, Bluetooth has been around forever. It's a mature technology. It's existed for a long time. It's not terribly exciting anymore, but Bluetooth Low Energy is something that I've been doing wireless for many years. It's something that's got me much more excited than many of the other different standards and technologies that I've worked with. They all have their own problems they're trying to solve, and they all have their own little niche. But what makes me very optimistic about the future for BLE is that it's a universal gateway to almost every phone in everybody's pocket as of about 6 months ago, or a few months ago, now that it's in Android 4.3 and higher. So you have one easy to understand format that can talk to just about anything. It works in iOS 5 and higher, Android 4.3, Windows Phone, BlackBerry. Basically anything that somebody will purchase in the last 12 months and moving forward as Android support sort of makes its way into more phones. You have a very low cost and easy gateway to access people's phones with a fairly low total BOM cost and a low sort of power budget required for that, which is, I think, opens up a significant amount of opportunities specifically for iOS devices. It's traditionally been very difficult to get into, especially for small developers, to get into sort of the iOS platform from a hardware point of view, because there are a lot of hoops you had to jump through with classic Bluetooth. There are no longer any specific requirements to develop a hardware device that can talk to iOS, which I think is a significant game changer for a lot of smaller companies. Just because all of the Bluetooth connection and transmission is managed on the application level, so you don't need to get the same sort of verification process that you had to traditionally. So if you're a big company, that's not necessarily an obstacle, but if you're 2 or 3 people working on a prototype on a tighter budget, this can be a very significant benefit for you and a significant reason to take a serious look at BLE. So if you look around at what's happening today with Bluetooth Low Energy, there is a significant ecosystem out there. It tends to be fairly concentrated on the personal fitness and personal healthcare market, and there starts to be a few products around proximity. So there are, more than 100 products out there that are using this today, but they're fairly concentrated in these two domains. There are still many opportunities in there. There are many interesting healthcare and personal fitness applications. There are many areas where you can still stand out in this area, but today the situation is that largely you'll see it in some well-known products like the Fitbit. Nike has come up with a shoe model, for example, but there are many products using it today in this sphere. What's interesting, I think, today is to think about where is this going now that you have one sort of universal language that can talk to just about any smartphone or any tablet, and increasingly any PC out there. Where is this going? That there are clearly some huge opportunities out there for small companies. If you look at the projected growth for sort of the accessory market, or whatever you'd like to call it, you can see that starting in 2014, the market is relatively small, at a projected $50 million in annual sales. But you can see for every year up until 2020, that market is predicted to at least double or more. So there are many, many opportunities for products that people have not thought of. Now that I think this is particularly important in that there are many problems if you're communicating with a smartphone that are now easy to solve that were not easy to solve before. In terms of user interaction and a means to display data, those are significant and expensive problems to solve. If you have to throw an LCD on your product or some way to easily interact, those were difficult manufacturing problems, those were difficult sourcing problems. You could easily add $10 or $15 to your product. Whereas now that you can offload that rich user experience and the data collection and the interaction with the user to a device that they're already comfortable using in their pocket and they've already paid for, it significantly lowers the financial barrier to come up with creative solutions and to come up with interesting ways to present that data and to interact with people. So there are many, many opportunities, and I really think for the kinds of people who are likely to be interested in mbed, there's a lot of overlap here, because the current Bluetooth low energy market, because it's very centered on fitness, there are still many, many other opportunities where you can become the number 1 or the number 2 person in your little silo or in your corner of the market. There are many products that people have not thought of, and now is sort of the right moment to be able to jump into that and to come up with those creative solutions to those problems that people don't necessarily know that they have yet. So how does BLE work? I can't really go into all of the specific details on the PHYs and the radio front end and all of that. Basically, all that really matters if you're interested in making a product is the data communication, or at least the key thing that I would like to communicate is the very simple data model, because essentially you're most likely to just be pushing sensor data out. So essentially BLE is based around a very simple premise. You have services and you have characteristics. You can think about it, if you're coming from a programming background, you can think about it as a service is sort of a class, and the characteristics are the individual fields. So if you take a look at the example on the right here, we have a heart rate monitor service, and inside that heart rate monitor service you have values like a heartbeat and the sensor location. So every BLE device is going to implement one or more services, and each service will have its own unique ID number, which will be either a 16-bit number, which is predefined in the Bluetooth specs, for a known service and a known value. This is what allows any Bluetooth device to communicate with any other device in a known way, in the sense I can plug in any heart rate monitor and my heart rate app will know that it's a heart rate monitor, because I'm following the specific contract that was laid out, that I have a 16-bit ID that's a known value, and I have a characteristic with a 16-bit ID with a known value and format. But as you'll see a bit later, it's very easy to implement any of these specific services and characteristics. Much easier than, it follows the same idea as USB classes, but it's much easier to implement. So each service, as I mentioned, will have one or more characteristic, and each characteristic also has its own UUID, which is your 16 or 128-bit ID. Yeah, sorry, as I already mentioned, you can either use predefined services. There's about, I think, 20 or 25 existing services that are defined today by Bluetooth, and the list is growing. You're also perfectly free to define your own custom services, and it's relatively trivial. The only difference is that for your own custom services, generally you have to use a 128-bit ID, just to ensure that the values are unique and there's a non-existent chance of overlap between your ID and somebody else's. So BLE also supports, you may see the idea of profiles. Profiles are just sort of a higher level abstraction. Basically, it's a collection of services. A profile that you see a fair amount of people talking about around BLE is the proximity service, which combines the link loss and a couple other services in one. It's a higher level contract that says we have this service, and this service, just so that you can have one universal device that's understood by other smartphones or tablets. So what have we done specifically then with mbed? We've tried to make this as easy as possible, just to fulfill those required contracts and to start to push data out. So we've been working for a couple months now on a BLE API, just to try to really simplify things as much as we possibly can, so that you can focus on your data and not have to focus on digging through the 1,400-page Bluetooth spec and to read through 30 different PDF documents. We've tried to make it as simple as possible. And the API that we're still working on this and trying to improve it and get a sense of what the best flow is. But for the moment, what we've done is we basically provided a simple abstraction with your services and your characteristics, because that's essentially the core of the whole process. We have a class for a service and a class for a characteristic and a simple abstraction layer for the hardware. At the moment, we're working with the NRF 51822, but the goal is to enable this simple API to be able to be portable to any other Bluetooth radio out there as more and more start to come online. There's a few out there today, but I think it's a market that will continue to grow. So we have the flexibility in the future to add other radios, or for end users to be able to add their own. So you can see here just the simple abstraction of services and characteristics. With you've got your 16-bit ID here, which is defined by Bluetooth 18OF in hexadecimal, and the battery level, you can see the 16-bit ID with some additional arguments to say the number of values, etc. But we'll go through that later. So in a few lines of code, essentially you can have a Bluetooth low energy device up and talking to your tablet, as we'll see here. I'll just give you a really quick demo. I've got to just switch the cable here. Using the heart rate monitor service, which it's a relatively simple service with just a couple values where you can update the heart rate value and say where the sensor is located. Just a second. Plug this in. So yeah, if we look at the code here, you can see there's basically I've defined 3 specific services in my code. I have the battery level service, which is just generally, it's a good idea to include it just so you can dynamically update the battery level and warn people when it gets lower with, again, our Bluetooth ID. I have a heart rate service, which has 2 mandatory characteristics. And if you look at the code here, you can see there's a URL that will redirect you. This is the definition from the Bluetooth standard of how the contract that we should have for heart rate. It's very easy to understand. In 15 or 20 minutes, you should be able to make sense of it. But just to show, the information is very easy to access, and it's very easy to implement services and characteristics that are compliant with the Bluetooth standard. And I implement a second service called the health thermometer, just so I can show two different demos. Basically, we just need to declare our objects with the service and the specific characteristics. We need to add the characteristics into the higher level service. So for example, for the battery level, I add service, I add my battery level characteristic, or for the heart rate monitor service, I add my heart rate as well as the sensor location. So it should be relatively intuitive for anyone doing the development. I reset my radio just to get a clean start with the radio abstraction layer. And then it's basically just as simple as continually calling the radio.update value function, which will update the sensor data on the low-level radio and push the data out to your iPhone. As you can see a bit further down here, basically this whole demo just runs in a while-one loop, constantly updating the heart rate monitor and the temperature. So one of the key advantages of Bluetooth, as I mentioned, was the connection time. If you're used to traditional Bluetooth, it can be a pain to get everything set up. So you can see here, I have this is just a simple Nordic app that you can download off of the App Store. If you can see, if I click the connect button here, it takes maybe less than half a second to get a connection, and sometimes it's maybe 100 milliseconds. You don't have to go into your config panel. You don't have to mess around with any other settings. It's just sort of intuitive. I can see my battery level, 72%, and the signal strength. And using the API, you can easily add some additional sensor info through the API, like the device name, which I've just said is mbed, a unique serial number, your firmware number. All of this is based around standard Bluetooth services. So it's relatively easy to extend, and it's relatively easy to provide that sort of key information and a custom experience with only a handful of lines of code. So yeah, I think I've been doing wireless for a long time. I've used a lot of different standards. I like 802.15.4 a lot. Everything has their niche, but Bluetooth Low Energy to me is something that really, I think people underestimate the potential value for this, and I really think in the months and years coming forward, there's a huge opportunity, which is why I'm really glad to see it get into the mbed API or into the mbed platform, because I don't know what people are going to do with it. I don't know what I'm going to do with it myself. I have some ideas of what I'd love to play around with, but I really think there's going to be some fun and some interesting applications around here, if we can just get the right creative people to get their hands on this and to take some idea and to put it into practice. Things like, when you think how many years ago before Dropbox existed, I don't know how I would live without that today, but I didn't even know I needed that problem. And I think there's a lot of situations like that where if we get the tools into the right people's hands, we can come up with interesting solutions that we didn't know we needed or wanted. And I think these kind of APIs go a long way just to make that easier, so we can get the technology out of the way and get that into the hands of the people who can come up with those creative solutions. So yeah, I guess that's it for my demo. We're still working on this. I mean, there's still some details to work out, but I think there's a good future for the technology, and I'll be glad to see people give some feedback and play around with it and let us know where you want to take this. So any questions? Or yeah.
So we've recently done a project with the same NRF, with the Bluetooth module.
Yeah.
And it's a hell of a fast-moving SDK. There's constant updates coming out for it all the time.
Yeah.
So who's going to be working on that? Is it you, or is it Nordic, or is it open? Is it how's that going to work?
Well, yeah, for the moment, the firmware, as you said, it's still kind of in flux. We've mostly been concentrating on the public API on the mbed side, simply because the firmware is a moving target. I've been focusing on 5.1.2 firmware, but yeah, it's a moving target. So for the moment, I'm kind of treating the hardware side as a bit of a black box, simply until it's more stable, and just trying to define a good public API into the hardware. Afterwards, how we will handle sort of the low-level abstraction, that's a separate problem, but we've intentionally put in some abstraction layers just to try to ease that process, so that, I mean, every 3 months there's a new firmware release from Nordic. So it's a new chip as well, so there's still a lot of bugs, and we're just trying to find the the right approach to have a nice stable firmware before we sort of put everything out there.
So their plan is to put this into their release cycle as well.
Okay, right.
So it's now, we're collaborating on this, and it's now part of. When we release it, it will become part of one of the store's platforms. And internally, we'll do some of the work, and they will do some of the work. But that's the plan.
There was another question back there. Yeah.
A question, timing for integration with Sentinel and the encryption layer. Is there a plan for it?
I can't speak myself for Sentinel. Yeah, please.
Perhaps wait till the back store.
Yeah, there's a presentation in a few minutes about that. So.
We'll talk about Bluetooth Low Energy. 6 panel with Bluetooth Low.
Yeah.
We'll talk about that.
That was the question, was it?
It was.
Okay, yeah, very, okay. Let's talk about that.
There are some security possibilities with Bluetooth Low Energy as well for AES encryption, etc. Again, I don't want to go into all of the specific low-level details of what you can and can't do, but the possibility is there to secure your communications as well, to a reasonable extent. Maybe we've got time for one or two more questions. I think.
I was going to ask, is there a way to confine who you're talking to? If 5 people are wearing heart rate monitors, you only talk to one of them.
Yes, actually, if you try to scan right now, you won't see this device because I'm connected. As soon as I establish a connection, it stops advertising. It depends. That's a hardware-specific issue, but generally, with most of the hardware, yeah, you can control the level to which you expose it and the advertising delays, and you can have a specific contract that only this device with this ID can talk to me. So there is a reasonable amount of fine-grained manipulation possible with who you talk to and who you trust, or if you need a key if you want to encrypt the data, etc. Yes. Yeah, you.
There's no pairing here, right? So, I mean, I understand you have to connect to it, but then you don't have to pair 2 devices.
No, that's what's great. It's 10 milliseconds. You click your connect button, it's done. There's no key to enter. There's no control panel. Maybe you have to turn Bluetooth on, but that's what makes it so great from an end user point of view. It's just sort of seamless and it works. It's like you plug your USB mouse in, it just works. That's what's I think one of the big things that differentiates Bluetooth Low Energy from Bluetooth EDR or some of the earlier predecessors. It's relatively seamless, and it all happens. If you're talking to an iOS device, it all happens on the app level. So there isn't. You don't have to worry about these kind of config issues to the same extent.
Are these iPhones or whatever, are they bimodal? You can talk to over Bluetooth?
It depends on the device. Some devices, it really depends on the specific tablet or phone module, as well as the radio that you're using. So yeah, it's in principle yes, but it depends on on the devices in question. I mean, so some devices can talk to each other. Some support. If it supports Bluetooth 4.0, generally it also supports Bluetooth Smart. But there are devices that are only Bluetooth Smart that don't support the bigger standard. So again, you can get into a lot of details, but if it supports Bluetooth, sort of the big brother 4.0, it also supports Smart.
It's automatic.
Yes. Well, the hardware functionality is there. Maybe the phone manufacturer won't expose it. That's their choice to make. But in principle, any device that supports Bluetooth 4.0 also supports Bluetooth Smart. But you can have low-cost devices that are only Bluetooth Smart, and they only implement a subset of the bigger standard. So it depends on the engineering choices that were made by the chip manufacturer as well as the device.
When your app is talking to the device, when the device doesn't stay on all the time, how does it know that it's supposed to receive something? It's always on and off.
You have a schedule. Basically, when you configure the device, you have a configurable sort of delay between, I don't remember the exact values, I think it's 7.3 milliseconds up to 4 milliseconds, and you set the delay between the transmissions. Or if you want to constantly send advertisement data or whatever, or it will just stay off until you add new data. So for example, my heart rate, I can configure it that it will not transmit anything. I can send 100 values, but it will only turn the radio on and transmit when the value is different than the last value. But the actual delay between the individual frames is configurable. But it's basically you're just sending data out, and the device here is always listening. The low power is on the actual hardware side that it shuts off, but my tablet will always be listening. You don't have the same power constraints, and it's we're talking a few milliamps. But it's this that will shut off, and it will just transmit out. So if you need a response back, then basically what you have to do is this will send out a request to the tablet to say, look, give me this data, and then it will wait for the response if you indicate that that's the kind of transaction you want. And there are several types of transactions. You can say with notify or indicate, and you can get an ACK back. So it's you have the flexibility to say whether you want a response or not.
Does it have a stack so that it can differentiate between if I have 10,000 iPads trying to talk to that thing, or another low power device also transmitting, and be able to determine which connection is used?
You can look for, you can say, I only want to talk to a specific ID. So yeah, there is the possibility to look for a specific device. You can also bond two devices together if you want to do that, but there is the flexibility to address only one device, or to limit only one connection at a time instead of broadcasting to everybody. So there's a fair amount of flexibility there.
What's the maximum distance?
That's hard to say with anything RF because it depends on how well your hardware is designed. You can intentionally choose to have more or less transmit power. I would say I had no problem going to the back of this room, for example, with my tablet, and I can get a reliable signal at the back of this room. Across the street, it's not going to happen, I think, but it's optimized for I would say a few meters range around it. But you can line of sight, you could go to the back of this room. No problem.
I was just wondering, is it low energy? I mean, it's lower than the standard. What's standard?
Well, that's a bit of a. It's low energy in the sense that it's optimized for low power. Traditional Bluetooth, it's on all the time. The connection is constant. This shuts itself off, except when there's transactions, and it's very heavily optimized to keep the radio off as much as possible. So there are just some design decisions there. Low power is a vague term. In the sense, low power might be 10 microamps to you, it might be 5 milliamps to me. So, but it's significantly lower power than classic Bluetooth. And there are a lot of engineering and design decisions to reflect that. I think, if you have some more questions, feel free to come and talk to me afterwards. It's an interesting technology. I would love to hear what people want to do with it as well, what they would like to see in an API. It's still early days. So yeah, if you've got some questions, feel free to come and find me afterwards. Okay, thanks.